for an update on the OpenET API. So really happy to have this hour and a half to talk with all of you. We have a couple of updates, improvements to the API to share. We also know our API working group has grown rapidly over the last few months as we're working towards the public release of the API. And it can always be helpful to have a chance to get a quick introduction, an overview. Will Carrara will walk through some of the commonly asked questions and challenges folks have encountered as they start to use the API. Walk through examples of some of the common ways that people have been using the OpenET API to retrieve data, and then we'll open it up for roughly 45 minutes of question and answer, as well as feedback. We really appreciate everyone who's been helping us with testing. It's resulted in significant improvements to the API. I very much want to compliment the work that Will Carrara, Bodo Guzman, Jody Hansen, Britta Dauder, and others have done on the API and the documentation, I think, to make it something that will be powerful and highly useful for water resources management and agricultural producers, hopefully for many decades to come. With that, I will pass it over to Will, and then I'll be online. If folks are having any problems with their API keys, please just put your email address, username in the chat, and I'll help you fix those while Will is walking through slides. This hour and a half session is being recorded for folks that are unable to attend, so we will be recording today. With that, I'll pass it over to Will Carrara, who has been coordinating and leading the API development for the OpenET team. Will.
All right, thank you, Forrest. Thank you, everyone, for being here. We'll have a lot of material to cover, so I'm going to get right into it. Just want to check, is my screen coming across okay for everyone?
Yep, we can see it.
Yeah, it is. Yeah.
Terrific. Well, for just a quick overview of what we're going to go over today, we're just going to cover what is the API. We're going to go over the main components that the API has with the raster and the geodatabase. We'll do a high-level walkthrough of just what the main supported endpoint types are. I'll do a walkthrough of some of those endpoints in our user interface as well as programmatically. We'll talk about some new developments in the pipeline, and then as well as our 2022 and 2023 roadmaps. So just for reference, if anybody here is kind of new to the group, I'm just going to be giving a very high-level overview here. So OpenET is the data explorer is probably what most of you are familiar with. And the API is an application programming interface, which is the programmatic way that this application is supported. So what is the OpenET API? So it's essentially an asynchronous distributed task queue. It's built on top of Earth Engine. We use a serverless cloud computing infrastructure structure to support all of this. So at a high level, we take satellite imagery that's ingested into Google Earth Engine as well as some meteorological data. We do a lot of modeling to calculate the various models used in the OpenET ensemble. That data is then populated into our geodatabase for millions of fields across the Western United States. And on top of this, we built an API, which we are looking to publicly release early next year, and a little bit more on that later. So the two components of the API are the pre-computed field boundaries. This is stored in the geodatabase. So when you click a field in Field View on the Data Explorer, you'll see that each of those is going to immediately hover into like a time series. And all that is doing is just retrieving data that we've pre-computed and stored in that database. If those field boundaries don't work for one of the fields that you're interested in, or if you want to retrieve a subset of fields, that is what the raster API is used for. So this allows you to draw custom polygons, upload shape files, and retrieve more custom data. So the types of endpoints that the OpenET API supports are kind of broken into four major categories. Time series endpoints are just going to return either a CSV or a JSON of time series data for that field. We have export-based endpoints, which are going to export the raw raster geotiffs from the OpenET data services. Metadata endpoints allow you to kind of get information on the data that you're extracting. So if you have an area that you want to learn a little bit more about where the collection, where the data is coming from, what was the last time data was ingested for that region, those are the endpoints for you. Lastly, we do have visual endpoints. These allow you to just generate, nice visualizations for your region, whether that be a graphical time series or a series of images from that data. And you can upload, custom color palettes and really tailor those for your needs. So I'm about to do a walkthrough. So if anybody would like to follow along with this, if you visit auth.etdata.org, you will be able to retrieve your API key. It should look something like this. If you do not have an API key, again, just put a note in the chat. API keys do expire every 6 months. So I know a lot of users, if you haven't accessed the API in some time, one of the first things we'll be doing is checking the validity of your API key, and it might just need a refresh. So with that, I'm going to switch over to the walkthrough. So visiting auth.etdata.org, you can copy your API key and then hit the Access API button. What this is going to do is just bring you to a OpenAPI kind of user interface. So if you click the authorize button and you can paste your key into the authorize there and click authorize, what this is doing is just allowing you to access the endpoints. So they are restricted. And the first thing you need to do is we'll just quickly validate the token. So this endpoint is built on a framework called Swagger. And all you do is you'll click the endpoint you're interested in, hit the try it out button, and if you hit execute, it's going to run that query for you in the browser. So what you'll see here, it generates a few things that are really useful. A curl command, this is what you can use.
Hey, Will, pause for
Yes.
just 1 second. There was a question from
Oh,
Steve.
yes.
Go ahead, Steve. Steve, did you have a question? You may be on mute. Okay, Steve, if you have a question, put it in the chat. And I'll be
Yeah,
sure to...
I'm sorry, that was a misfire.
Oh,
Continue.
no problem.
Thank you.
All right.
Okay.
Go ahead.
So just for everybody here, you'll want to validate your token just to make sure that it is working correctly. You'll see a curl command generate. This can be pasted into your computer's terminal to directly run that command. You'll see a request URL generate, and that just kind of breaks it down, the command, in a more readable format. You'll see the response details. So 200 is a successful HTTP response. And you'll just see, OpenET, your API key works. You could download the response and as well copy it to your clipboard. So once your key is validated, you can use the following endpoints to see, check the expiration date of your key. So, and some of you may have your keys expired, in which case we just need to refresh them, and you'll put a note in the chat if that's the case. So again, you can see that my key here is expiring in December, so we're okay. So the next endpoint I want to cover is going to be the quotas endpoint. So currently, prior to public launch, we have a provisional quota system in place. It allows users to just extract subsets of data here. Again, we're trying to make this as generous as possible, for testing purposes. So you can see this is broken down into the following categories: acre years, acre months, acre days. And so this is really, you can interpret this as saying, if I am extracting, a field that is 100 acres, 12 months of data, it's going to be the number of time steps times the area of the field. And that will be just subtracted from this, acre months category here. This resets currently the first of every month. So you'll see these values reset. And then there's some more information on all of this in the documentation. So if anything, if I'm going a little too quick, all of this information is there. So moving on from the kind of home endpoints, we have the time series and metadata endpoints for the geodatabase. So I just wanted a quick note. You'll see this first get endpoint here. Time series features for a field ID. So this is a testing endpoint that is going to be removed. So the output of that's going to look a little funny, but that was something just used internally. So that will be removed after this. So these following endpoints here are just going to retrieve from the geodatabase. So if we want to, say, get a time, the annual stats for a specific model, looking at ET, looking again at a specific year, let's say 2018. Right here is what you'll paste your field ID into. So every time you click one of the fields on the Data Explorer, you can, on the graph that generates, you'll notice that the field ID also pops up there. So you can paste that directly into here and then run the following query. So this is going to output the results for the aggregated annual ET for the CBOT model, in this case for 2018, and you'll see the results here. So these are again just pulling data from the pre-computed boundaries in the geodatabase. I'm going to kind of skip most of these endpoints. They're fairly self-explanatory, but I'm going to focus a little bit more on the custom data endpoints via the raster API section.
Hey, let's pause for just
Yes.
1 second and see if there are any other questions and just make sure everyone's got their API keys squared away.
Oh, certainly. Yes.
Any questions so far?
So, Forrest, this is Brian Thorson.
Hi, Brian.
Hey, how are you? I got a couple quick questions. I apologize. I got on a little bit late, so maybe some of this has been covered. I had something come up this afternoon, so I'm going to only be able to be on for about the first half an hour here. Is the 11.4 one the same, or is that different?
It'll be the same. Yeah, we'll cover
Okay,
the same.
good. Okay, and then I've got a GIS person that's helping me that I'll email. I emailed Garshwa earlier, and I don't seem to have the right email, but I'd like to get this GIS person involved in the next one, and then I guess it'll be less. Then I'll start new in the next one. So
Sounds good. We are also recording it, and if you put a name and email address of the person in the chat, we're happy to invite them to the event on the 4th.
okay, great. That sounds good. Thank you very much.
Good thing. All right, go ahead, Will.
Alrighty. So moving on to the raster endpoints. So this information, again, I'm just going to highlight, is all in the documentation. Forrest, if you want to paste, this might already be in the chat, but a link to the documentation, it is just openet-github.io. So right here, if we're wondering, I want information on the raster endpoint, the time series point endpoint. You're going to see a breakdown of each of the parameters used. So whether, in this case, the long is just the longitude, whether this is required, if there's a default, and then an example of what that might look like. So all of this information is in the documentation. So if you, I kind of move through this and you're wondering, oh, what exactly does the units parameter do, or what are one of the optional inputs? This is going to be where you can find that example and then what the return looks like for either a JSON or a CSV. So back to the Swagger page here. I believe it's this one. So we have the following options. One of the models, so in this case, we can do the ensemble, we could do SIMS, PTJPL, CBOP, any of the OpenET models. The variables, so in this case, we have ET, reference ET, ETO, ETOF, the fraction of reference ET, NDVI, precipitation, etc. Our period that we want to extract data to. So this is, in this case, I just have 2018 filled out here. The reference ET source parameter is going to be what we use for the, in this case, GridMet is a CONUS wide product. We, in California, the state product is spatial SIMUS, so we do have the option to put, SIMUS in here if we want. I'm just going to leave it as GridMet. This provisional parameter is just something that you can always kind of click on to true. This may be something that we remove and just default to true in the future. But for now, this just allows you to get the latest data. So this is relevant if you're querying, 2022 to current. You'll want to use that provisional true. The units parameter is just going to control whether the, in this case, the ET is going to be either in millimeters here for metric or inches. The coordinates, of course, are going to be your longitude, latitude coordinates. Interval is a parameter where you can control whether this is going to be the monthly time series that you receive or daily time series. So I'm going to get a little bit more into the nuances of what there certain restrictions are for querying daily data. Moving average is a parameter which just allows the option for daily time series to smooth that out. It creates a moving window of an n number of days on either side to smooth out the time series. It just takes the average. In most cases, you'll usually always have this set to 0. Again, this will only affect a daily time series. And then the output file format, in this case, JSON or CSV, whatever your preference is to work with. So once we click this is just going to do a quick query. Again, we see that curl command generate. We could take this, paste it into our terminal window like so, and get the same data right back immediately here. So we see our time series generate. In the case that we chose JSON data, we'll just see a time and the ET, which is the variable that we extracted. If we want to download that data, we can just click the download button. If I open it up, I'll immediately see that in a JSON format here. So that is data for a longitude, latitude point. If we want to do something for a polygon, this is how the draw custom area tools work.
There's a question.
Oh, yes, go ahead.
The question was, can the interval also be set to annual?
So currently, for the raster API, we only have the options of monthly and daily. I'm looking to build in the tools that allow both annual as well as weekly aggregation, just to make that a little bit easier. But for now, we just have it as monthly and daily. So if you want to make a monthly extraction and then just aggregate that to an annual time step, you can just do that via Excel or Python. But we will be looking to add those tools.
And then there was another question that I can answer about the difference between the OpenET API and the GitHub repos. And I'll just say the GitHub repos are going to house the codes to run the models themselves. So the codes, specifically if somebody wanted to run the models for a different area or copy those repos and make changes or explore improvements to the models. The API facilitates direct access to the OpenET assets on Earth Engine. And we are currently working with Google on the process to make some of the historic assets, to add them to the public data catalog on Google Earth Engine. I think those are the questions so far.
All right. So I'm going to move on to the time series polygon endpoint. So if anybody is not familiar with working with APIs, you'll see a couple things here. You'll see this one is a GET request. This one is a POST request. The way that this works is the way that POST requests allow you to enter data in what's called the request body. And this can be as long as you want. So this allows the support of more complex geometries. Instead of this being just kind of a generic square geometry where the vertices are the longitude, latitude points, if I have something like a center pivot and a lot more geometries, you can query that in here and not run into any types of restrictions with the character limit for your browser. In a GET request, everything is passed in the URL. And so those parameters, there is a character limit for every browser. So this endpoint looks a little different in the way that you format everything. But again, the parameters are very similar. It's your model variable, start date, end date, reference ET source, provisional units. The only difference between the point and the polygon endpoints is going to be the pixel aggregation. So in this case, we're going to take a mean of all of the pixels within the geometry. And then the geometry parameter here is just going to be the bounding box of everything that I want within that bounding box. So running the same query here, we'll see a result that's going to be formatted the same because I used JSON output, and give it just a moment to run. And again, we'll see this curl command generate, and again, the resulting time series for the area that I've selected. A quick kind of useful hack here is if I go to explore and I just quickly want to use the get the geometry, what I can do is use the draw custom area tool, zoom into the area that I'm interested in, draw my field, run the time series, and you can use this copy shape to clipboard. So if you want to use the API and just quickly check that you want a custom shape, you can copy that shape to your clipboard, paste it right into here, make that same query, and then that will format. So the format of the geometry, this is again in the documentation, is a longitude, latitude separated coordinate system of the vertices of the polygon. So moving on, the time series multi-polygon. This is an endpoint that's very popular. What this allows is for users to use a shape file for data extraction. So what this looks like is if I have a shape file uploaded as an Earth Engine asset. So here's an example here where I've created just a very simple shapefile with a few polygons. The reason currently OpenET just supports retrieving shapefiles as Earth Engine assets, so you'll need a Google Earth Engine account. You'll just, once you create one, you'll have access to this dashboard. And then every time you need a new Earth Engine asset, there's this new button on the Assets tab just allows you to upload a shapefile. And at that point, you can just select your shapefile, upload it, and you'll see it show up in your personal assets. To use it for the multi-polygon endpoint, you'll take your asset, you'll just need to hit the share button, and you'll share it with OpenET at googlegroups.com. And you just give it read access, and that's all you need to do. At that point, you'll be able to use the multi-polygon endpoint using the table ID, which is right here that just gets generated for every asset that you have. So I'll go over this in just a minute. And again, this is in the documentation. I know I'm throwing quite a bit at you. But what the multi-polygon endpoint allows you to do is really cookie cut from the rasters. So it takes your shapefile that you're interested in. It's going to cut out, like so, information out of the OpenET rasters, and then return this as a time series for the regions that you have selected. One requirement for every shapefile for Earth Engine is that each polygon needs to be given a unique identifier. So if each of these, in this case, I just have, 1, 2, 3, 4, 5, to the number of polygons, but you can make this as complicated as you want. So for whatever identifying system you have, you'll need that information as well. So if I move on back to this request here, I will see again very similar parameters. I want whatever model I want, the variable I want, the time range I want that information, the reference ET source, provisional data. This is what we're seeing here for the shapefile asset ID that allows us to define the geometry that we are interested in. So in this case, I just copied and pasted that table ID for the shapefile that I've shown you already in there. The monthly parameter, the interval parameter, in this case, I'm just selecting monthly. And then this include columns parameter. This allows you to select different attributes that you have in your shapefile. So if you have some other information in there and you want to, at a later point, aggregate, the ET data to that information or group by or whatever type of analysis you're working on, you can just do a comma separated list, of this for the things that you're interested in. Like if I had another column named area, I could just include that and it would also be included in the output. And you'll see what I mean in just a moment. In this case, the only attribute in the shapefile I have is just called ID. So the file name suffix parameter, this just allows you to name your file to keep track of it. One important thing to note is every file, we're going to tack a few things onto it. So I'm just going to go back to my slides here and just give a quick note on what these export type of queries look like when you do the export. So once that export is completed, you will be entering the OpenET queue. So the time, if you have a very large export, it might take some time to finish. If a lot of people are using the API at the same time as you are, it will take some time to finish as you enter the queue. So every time I run that request, instead of being granted the data instantly back, such as in the point and polygon queries, you will instead be granted back a message that is just this JSON string here. So this, you will see something that, you've labeled your image. So we tack on a unique identifier to every file name suffix. So you'll see a 4-digit number here. You'll always see the model that you used and the variable that you used. That will also be kind of tacked on. And then in this case, I just named this public_demo. So you'll also see the state just saying, this is ready to be submitted. A new thing that we've recently added is this ID. So this allows you in real time to track the file as it is being processed and check where it is in the queue, if it's done, or if it's pending to be submitted. And I'll give an example of this shortly. And then finally, this destination. This used to be called bucket_URL. So every user we create a Google bucket for you to store data in. Every file in that bucket has a 30-day lifetime. So because we are leveraging the Google infrastructure, we also get all of the Google security features. So that means that every single file, we need to grant permission to who can access that file. So what we've done is a lot of people have non-G Suite enabled accounts. So in some cases, a work email, a .gov email, something that doesn't have that, a Gmail type of address. What you can do to retrieve your file is you just include this keyword public, just _public, anywhere in the file name suffix. All this allows is the URL will be retrievable to anybody with the URL. Otherwise, you'll notice that the Google storage account will only work with your email associated with your OpenET account. So this is something that kind of trips a lot of people up when they're exporting data. They'll make an export, they'll see that it's done, and then when they try to click the URL to retrieve the data, they'll notice that, oh, you don't have permissions for this. So in most cases, I usually just keep the word public in the file name just to make it accessible. So what that looks like in practice is, in this case, I will make an export using the following parameters, and I will see that similar output. Ensemble, multi-polygon public, this is saying it's queued, and here's my link. So if I try to access this link right now, I will see that this link will throw an error, just saying, hey, this doesn't exist yet, it's not finished. And that's just because it just added to the queue. Usually these take about a minute or so, a little bit less, a little bit more, depending on the size of the extraction. But what we can do is take that ID and run the check status endpoint. So if I paste the same ID here, this just allows us to track where is that file in the queue. Is it done? Is it still being submitted? And this here, we'll see a thing that says status running. So this can either be pending, meaning that it hasn't been submitted to the queue yet, running, it's actively in the process of being completed, and then succeeded, meaning that it is done. So if I run this again, it will probably be done. Yep, succeeded. So now if I do that same link that I had earlier, if I just re-download that, we'll see that that file immediately downloads to my computer. So this is very useful to have that, to be able to track in real time where's your file going. Now, often is the case that you may lose that link, and I'll go over what to do in just a moment after we take a look at the output of this file. So the shapefile I had, each polygon just had a unique identifier, 1 through 14. The multi-polygon output has changed in recent updates. So we've now trimmed it down where you will see just the columns that you've requested. So in this case, I only requested ID. You'll see a time column, which is just going to be the date for the value, and then a column called mean. Prior, we were extracting various pixel aggregations. We were doing the min, the mean, the median, the max. And so people were getting larger CSV files, but the only value they were ever really using was the average value. So we've currently trimmed it down to just be using that. And then you'll also see an area column. So depending on the units that you've used to make that extraction, in this case, I used metric. So I will see area underscore hectares. If I had used English units, I would just see area underscore acres. So that's just going to be the area calculation for every polygon that you've used. So again, we'll see the following time series. Now, as I mentioned before, what if you lose this link? You're making extractions, and it's really easy to misplace it if you're making multiple extractions. We have this following endpoint, the export all files endpoint. All this is going to do is look inside your Google bucket and see what files have finished and are presently there. So if I click this, and again, you can limit this to however many files. In most cases, you'll probably only have a few dozen in there at a time because they recycle after every month. But we can see that these are all of the files that I have extracted with my account. So in this case, we see that file right there that I just finished, and I can just paste that link again and just immediately retrieve that data. This is going to be broken up into two sections, the time series section for time series requests and the raster sections for raster geotiff requests. So I'm going to just quickly do one of those before moving on to the next section. In the raster endpoints, you will see the raster export and the raster export stack. So the raster export is just going to export a geotiff composite with a requested time range for the data you're interested in. And again, it looks very familiar to the other endpoints. You'll see, the same options available, the model, the variable, your time range, reference CT source, and in this case, geometry. So I can just say, I'll just name this public test, and again, make that export. And what we'll see is a similar type of output, the status, your tracking identifier, and then again, the destination to retrieve that geotiff output with the geometry that I've specified. So the Swagger interface is something that's very easy to use if you're a little less programmatically savvy, but I'm going to do a quick overview for those of you who will be implementing some of these. You'll want to be able to access the API programmatically. So Gershaw, if you would paste that link into the chat real quick. This is going to be a public notebook, which I just drew up this morning. And it's going to look like this. This uses Google Colab, which is just a quick way to run Python or another programming language in your browser. So if you click the link that Kershaw is going to post in just a moment, you'll see a similar page that looks like this. This is leveraging a system called Jupyter Notebooks, where you run code in little cell blocks, and each block operates independently of another block. Really, what you can do here is just runtime run all. So I'm just going to paste my API key right here, where it says paste API key, and I'm just going to just run all of the cells. So this is just some starter code for you to access the API. You'll need just some generic function to be able to make requests to the server. So all this function does is you give it an endpoint that you're interested in. It takes in your API key. You give it the arguments for the endpoint that you want, and then whether or not this is a post endpoint or a get endpoint. So again, this is just using the Python requests library. It's a very straightforward piece. So something that you might want to do with OpenET's data is calculate the ET of applied water, for example, for a field that you're interested in. So I've gone ahead and defined, the endpoint that I'm interested in, the polygon endpoint. These are all of the arguments, just in a simple JSON data structure, of that endpoint. So again, that start date, end date, etc. And then here's a little bit, again, more of a complex set of vertices for just an arbitrary field I selected in Oregon. In this case, I'm going to want, ET, grid net reference CT source, etc. So for the following endpoint, we're going to need to make a couple requests. To calculate ET of applied water, we're going to both need the ET and effective precipitation data. OpenET is currently working on developing an effective precipitation data product that is still in the works. That is a very difficult problem to solve on a large scale. So for now, just a quick way that you could kind of approximate what that would be for your situation. And again, Forrest can elaborate on better methodologies to do this, is just using a scaling factor. So this function here, or this little cell block, is just going to say request ET data and precipitation data, and then just mash those together into a single little data frame here. So we'll see for that same field, both of these values. And then again, the calculation for effective precipitation will be, in this case, I've just set a scaling factor of equal to 1, assuming all the precipitation is effective. You could modify this to 0.8, 0.7, whatever it is for your situation. And then run through the calculation here where the ET of applied water is the ET minus the effective precipitation. And then you may want to calculate the volumes for this in acre feet. So in this case, it would be the ET times the area divided by 12. And then again, you'll get the following output here. So this is just some quick data manipulation with OpenET data. And then this exports that data frame that we've just created right here for you to download. So that is just a quick introduction into handling the data with Python. With that, I'm going to move on. I'll check right now if there's any quick questions before I talk about new developments.
I don't know if I caught exactly what you said about the precipitation. Is that already available, or is that going to be made available? What's the status of precip?
Yes. So OpenET currently uses GridMet precipitation. So if you query precipitation from OpenET, you're just getting the GridMet precip back. We're working on effective precipitation. And Forrest, if you want to elaborate a little bit more on that, I'll leave that one to you.
Yeah, so we're working on a solution for producing a gridded effective precipitation product. What Will has added in the interim is just the ability to scale precipitation if you have a locally calculated adjustment factor for your period of interest. So we've added that as an imperfect but temporary solution to let the user specify how they want to scale the GridMet precip if needed.
Thank you.
Alrighty, not hearing any other questions, and we'll have some time at the end for this, but on to some new developments for the OpenET API. We have done some continued work for short-term forecasting for both ET and reference ET. So this is a kind of a preview of what this looks like. We will be supporting this we're thinking, depending on the results of our accuracy assessments that are ongoing, a 7 to 14 day forecast for these products. This is something that has been definitely been a little bit in the back burner currently, just because we've been working on a lot of additional user support and added functionality and really scaling our servers up to be able to handle the public launch of the API. But we are continuing to do a full accuracy assessment to get within a very reasonable threshold for these predictions. This is another exciting development. So ET data is natively, we're leveraging the Landsat system, which has a 30 by 30 meter pixel resolution. So this is a question I pose to all of you. Is it better? Do you have a use for us providing tools to super sample to 10 meter data resolution or a higher data resolution? So we've kind of done some experimental work on super sampling, our native ET data as well as other data products we provide. So this is kind of a before and after of what these kind of look like. So if this is something that is a useful need for your applications, or if you're interested in this, please let us know. This has just been some ongoing development as well. We are. Oh yes.
The thing we've been debating internally is that on the one hand, for presentations, maps, graphics, we know the images on the right look a lot nicer. We worry a bit about giving folks a false sense of the spatial resolution of the data. So the images on the left are a more honest representation of the accuracy of the data. Sorry,
Yes.
just basic resolution of the data at that 30 by 30 meter, 0.22 acres per pixel spatial resolution.
Yeah, yes.
The
Yeah,
one
thank
on the
you.
right, if I can ask, the one on the right is it's looks pretty in terms of how meaningful the values are. I shouldn't count on those values as being meaningful. Is that what you're saying?
Correct. I mean, the super sampling probably does a reasonable job, but there will be cases where there are boundaries between different soil types, different land management practices, and we really can't say, where within a 30 meter pixel exactly where that boundary is. So,
My question is like, do you know how much it affects the geodatabase aspect, like on identifying what crop boundaries are? Does it have a significant impact on that or not?
it does not. The geo database crop types are set based on a majority vote algorithm within the boundary. So we take all of the 30 meter pixels either from the cropland data layer or from one of the state crop type data sets, and then we set the crop type in the geo database based on a majority vote of all pixels contained within the field boundary.
So, for example, if a field currently had one type of crop and next year it had two crops, but it was like a 60-40 split, you guys would just say the 60% crop, right?
Correct. Yes.
Okay. Awesome. Thank you.
Really, the field boundaries in the geodatabase is designed to facilitate exploration of the data and make it easier for anyone with a web browser to start to get a sense of the information. We know the crop type and field boundaries are, again, they're from publicly available sources. We know they are not perfect. And the ET data in the geodatabase is computed from the 30 meter resolution data. The option to produce the images, as shown here at the 10 meter super sample, was really more just for presentation purposes, just to make maps and for use in presentations or for integrating the imagery with other farm and ranch management applications.
All right. Yes. So thank you again. Would love to hear some additional thoughts on this as with ongoing development. So if you're interested, please let us know. We are working on a complete overhaul of the OpenET documentation system. So I have to admit, some of the documents that are publicly available right now are a little bit out of date. So they are currently rebuilding that entire system using a platform called Gitbook. So we will be launching this potentially late this year or early next year, but it's going to be launched prior to the public release of the API. But overall, it's a much cleaner system. It will provide some additional support for, multiple, using different curl node, Python, etc. And with that, we'll talk a little bit about the 2022 and 2023 roadmaps. So I'm just going to cover a few.
Well, let's pause for a bit. We've got a couple of questions stacking up, so let's take
sorry.
them before you move on to next things. So let's see. Let me go back. Jason was asking about limits for acreage from the API. Answered part of that. That we are planning to support queries of at least 50,000 acres for the general public, working to increase that if we can. We do have real cost for outbound data and potentially for some of the computing and API support. So trying to find that balance between not racking up a large bill for OpenET and maximizing access to the information. We are working on an MOU with Google. If we can, once that's signed, that will also give us a lot more confidence in our ability to increase the acreage. I will note that we are in the process of developing an agreement with the state of California that would allow each GSA to directly access the information and designate consultants, one or two consultants that would have unrestricted access to the API for the GSA boundaries. The support for the groundwater sustainability agencies in California is a high priority for us, and we're working with California Department of Water Resources to facilitate that. And as I mentioned in the chat, we are also proposing to Google to add data to the Google Earth Engine public data catalog. That data could be downloaded directly in its entirety through the user's Earth Engine account, and Will has some functionality developed for the API that would allow a user to access those assets without restriction using the OpenET API to take advantage of all the functionality within the API. That would be a convenience. Let's see. Another question, Will, that raster exports only return a monthly ET image, correct? Is it possible to get ET on a specific overpass date?
So currently, while we are supporting daily data within the time series based endpoints, we are still doing some additional assessments on the cost for doing daily raster geotiffs. For the public launch, we are thinking that we will turn on that functionality, but for now, we currently have the geotiffs restricted to a monthly interval.
I think we will be adding the scene assets to we'll be proposing to add the scene assets to the Earth Engine public data catalog, so that would allow the raster export to directly access the individual scene assets on an overpass date. So thank you for asking that question, and we'll add that to the development list for the API. There was another question, Will, about whether or not the geotiffs are exported in a cloud optimized format.
So we did do some testing internally. Funny enough, what I found while testing that is the cloud optimized format actually produced much larger file sizes than the non-cloud optimized format. So while that is something that we can support, I currently have that switch flipped off because it seemed to produce unnecessarily large file sizes for people.
Yeah, and then once we add the assets to the Earth Engine catalog, we might have that option for people to be a cog. So I think one of the questions was also if it was going to be part of the Stack catalog. Yeah, so we're working with Google to add it there.
And there's another question from Jeremy asking just that the multi-polygon daily ET time series is available now as an endpoint, or is that something that's on the roadmap?
Oh, that is available. That is available now. So sorry, Forrest, did you say daily time series?
Multi-polygon daily ET time series.
Yes. So with computationally, that is a very expensive call to return daily time series. So the API currently restricts for multi-polygon retrievals of 1 year of daily data at a time. So again, this is a tricky one to place limits on because it's very easy to create kind of a memory bottleneck. So OpenET is still restricted because we are built on the Google Earth Engine platform to the same types of computational things that you can do on Google Earth Engine. So it's easy to exceed your pixel limitations with very large shape files at daily time steps. So we do recommend, again, if you have a small shapefile in a reasonable area, and under 5,000 acres, you can request a year of daily data and shouldn't be much of a problem. But what's helpful to us is if you have your shapefile with a lot of complex vertices, if you're able to simplify that, that makes things a lot more computationally efficient on our end and allows you to kind of increase the data that you're able to request with that same shapefile. So yes, that answers that question.
There is another question about when you add the annual option, will it be in water year rather than calendar year? Good question. I think we can potentially support both.
Yes. We realize that a lot of folks operate on water years versus the traditional calendar year. So making it easier for people to get the data, quickly and not need to aggregate that on their own schedule. So we will definitely add the option to build that, yeah, as a API parameter, as just a flag that you can raise.
Thomas asked for daily data. How do I know the overpass dates? And we were just talking about that yesterday, Thomas. So that is part of the metadata we will think about, work on adding another to the metadata endpoint, or as another, especially for any time series retrievals that would flag basically the data from the overpass dates versus data that's been interpolated.
And just to add on that, one thing I was thinking about adding to the API in the short term will be an option to not interpolate. So this will just be a flag, interpolate false, and then the data that you receive is going to just be the true observations of the satellite date. And then you can yourself, if you choose an interpolation, or if you want to do a more complex level of interpolation rather than just more of a linear thing that OpenET does, that will provide that functionality.
And then there was a question about whether a polygon could have more than one overpass date. Yes, certainly there are places where we have overlap between scenes, and you can have multiple overlapping overpasses. So that is a good question and good point. The Camille asked for the 50,000 acres for the public API access. Is that per user? Yes, that would be per user. And is there a recurrence interval? Yes, I think currently it's refreshing monthly. We are going to need to set some total limits on annual usage per user initially. Andrew asked for the forecast tool. You showed an error cloud for that data stream. Is it possible to include something like this for the ET so users have a better feel for certainty for various models and the ensemble? You want to go back to that figure?
Yes, I'm sorry. You're seeing this the gray range here that just in this case shows a plus or minus 10% error threshold.
Yes. So Andrew, in the Data Explorer currently, and through the API, you can retrieve the model range, which is currently computed based on, I think it's 2.5 times the median absolute deviation from the ensemble. So we are using that as some indication of the uncertainty across the ensemble of ET models. So we are including something similar there. And in the Data Explorer, if you turn on the range, we are using that as an initial assessment. Of course, on the OpenET data.org, under the accuracy tab, we also have descriptions of the accuracies for the ensemble ET value, and will be, as John Volk finishes his analysis, adding updated results for the individual models as well. I think those are all the questions. If I missed one, please put it back into the chat.
A question that was asked in the chat was, what are the field IDs based on? And you said that the field IDs are set sequentially by OpenET. My question is if it's available for download, like if there is one shapefile where you can download what field IDs correlate to what shapes. Because if we submit the boundaries of a shapefile and say these are all the fields we want, I don't know if my boundary is splitting a field in half or not, because I just have the field ID. I don't have what the actual shape is.
Sure, I can answer that one. So currently in the geodatabase, there's a way when you submit a boundary to retrieve the field IDs, you can, I believe there's an option that says, whether it intersects, whether it's fully contained. and you can set that, to have the appropriate behavior that you expect. We are revamping a lot of those endpoints before the public launch. One thing that I think we're likely going to support is, small, again, correct me if I'm wrong, Forrest, retrieving subsets of the geodatabase geometries to a certain capacity. So where you can, add your, get a GeoJSON or shapefile export of, given some area, those exact boundaries and their respective field IDs.
Yes, so yes, we are working on adding that for the public release, and we'll let this group know when that's available. So yes, we realize that the time series from the geodatabase are a lot more useful if you also have the geometries to go with them.
Thank you.
Be adding that as well.
Alrighty. Barring no more questions, I will just kind of move on to the roadmap for 2022 and 2023. I'm just going to cover the first section and then pass it off to Forrest for the upcoming events. So back in January, we did add daily data support as well as the pixel level interpolation for that. We did add Landsat 9 integration. So we officially turned off Landsat 7 for all 2022 data, I believe. GeoJSON support is available. So for the multi-polygon export, you can get those geometries back out as a GeoJSON or as a CSV. We have been busy with a lot of compute optimizations. Overall, our system, there was a period of time where, as we started adding a lot of the daily data, certain data latency for request was getting a little bit out of hand. So we have been working very diligently to minimize our compute resources, just to make those requests much faster for every individual user, and then also just reducing costs by doing so. So we are working on a much larger system overhaul for the public launch of the API, in which we'll see significantly more compute optimizations coming forward and lower data latencies for individual requests. And Forrest, I'm going to hand it off to you for the upcoming things for the roadmap.
Thanks, Will. As we've talked about, we are in the process of proposing the OpenET historic data for addition to the public data catalog. We are working on testing functionality that would then allow API users to use their own Earth Engine accounts to access that historic data, so that the usage, exports, is all managed by the user. And so that should allow us to remove any restrictions from OpenET on access to that and use of that data, and largely because we would then not be incurring any costs for those calls. Next slide. As Will talked about, we are working on updating the user documentation. We welcome feedback on any areas of the documentation that need additional explanation or are unclear or would benefit from an example or even a short video. We're targeting late winter, early spring for the public API release. Part of that is dependent upon when we have the historic data and the scene assets added to the public data catalog. So that's our best guess right now. And we'll try to beat it, but it could also slip. Will highlighted some of the work on the short-term forecasting. That's something that's come up over and over again for our agricultural partners in terms of improving the utility for irrigation scheduling. So we are working hard on those 7 to 14 day, both the ETO forecast as well as the forecast of total ET. And we are continuing to work on the custom reporting tools that will provide a graphical user interface for the API that reproduces most of the functionality that users can obtain by directly accessing it, either through the API itself or using a scripted approach to access the API. So we may not be able to provide support for the full range of capabilities that's supported by the API, but we think we can handle most of them. So that would allow folks who have many technical skills but may not be programmers or used to working with APIs to obtain custom subsets and automated reports from OpenET. That's what is on our roadmap. And I'll pause to see if there are questions about that before I move on. Will, there's a question about any pointers to simplify multi-polygon vertices to query daily ET? And will there be functionality within the API to handle that simplification?
Yes. So that is something that I've actually done some internal testing on. Originally, we automated some of that simplification to flag if we saw a series of vertices that got out of hand. The previous way we implemented it, in rare cases, could result in a bug when while your geometry would be simplified, but the actual output would show with the area calculation would calculate like a very, very large erroneous number for that area. So while the data, the rest of the output would be fine, the column that includes the area information would potentially become inaccurate in certain situations. So we have not had the time yet to fully delve into that bug, but that is something that we potentially can support, that automated simplification of those vertices for the user.
Yeah, I think for now, one of the things we can do is add a Earth Engine script that shows you how to simplify it there, so you can actually have an image of what the geometry is going to look like. Because we can do it internally, but like Will said, we might end up with some errors there. Right? The fields might not line up, but I think we can add a sample script to do that on Earth Engine.
Yeah, I think we can display that. We might be able to run some checks. We do want to make sure the user is controlling the process of simplifying the polygons and is able to review and inspect them before they pass them to the OpenET.
And that can be done in ArcMap or QGIS or Earth Engine if you have an account.
And again, if it's something that's helpful to a lot of people, endpoints for shapefile validation, where you can, submit your shapefile, have it validated, flag anything that seems, a little unusual, like extreme vertices, vertices crossing one another. Please let us know if that's a series of endpoints that would be helpful for you to shapefile in, validated shapefile out, and then you can see the changes before and after by looking at those layers.
Asks if the bias-corrected GridNet reference ET will also be added as a public asset. Yes, we will add the bias-corrected GridNet reference ET as another asset. And Thomas asks if the new Landsat 9 data is integrated within 3 days. Yes, that's pretty consistently been available on Earth Engine within 1 to 3 days of satellite overpass, and those scenes are we're grabbing those within OpenET and running the models for them as soon as those scenes are posted. So typically we do have for Landsat 9 data available within 3 days of satellite. If there are delays in the availability of those Landsat scenes from USGS, of course that will translate into delays in processing from OpenET as well. Typically it's been within 3 days. Any other questions? General questions? Feedback?
Is there any intention to...
Go ahead.
Sorry.
Go for it, Paul.
Do you plan on implementing Sentinel data in your models in the future, or is there any capability of that?
Yes. The SIMS model in particular has a separate version that combines Landsat. Landsat and Sentinel. We can potentially also use the harmonized Landsat Sentinel data. On our roadmap for the science team is evaluation of different techniques for data fusion to try to get us closer and closer to the closer to a daily field scale land surface temperature. So looking at downscaling viewers with some combination of Landsat and Sentinel. Also closely following the development of the joint French and Indian Trishna satellite, which would be roughly 60 meter thermal data. I think it's 57 meters, something like that, every 3 to 4 days, as well as plans by the European Space Agency to develop a thermal free flyer that would follow Sentinel-2A and 2B in their orbits. So tracking all of that, and certainly for SIMS, that would be the first logical place to start to integrate the Sentinel-2 or the HLS data, the Sentinel-2 from the HLS. So, yes.
Cool. Thank you.
But it's not, it will take a little bit of work planning and testing, for sure. And was there a second question? And then we'll get to the additional questions in the chat as well.
On one of the previous pages with the custom reporting tools, I heard reference to a Python module. Is that something that's in the works, or are you guys just making and refining the API?
Yes, so that is a Python. That is where we would like to take some additional support and build out just a fully functioning Python module and continue to support that. That is something on the works, but it's a little bit in the back burner. So I think once we have a successful public launch early next year, that will be one of the high priority items to develop and support.
Thank you.
Andrea asks if we're still planning on a best practices manual. Yes, we are. We are still planning on that, and Rick Allen has a solid draft of many of the sections. So we need to carve out time to organize that, figure out where the remaining gaps are, and get that wrapped up. That probably won't cover the API and custom reporting tools. I think that will focus more on the differences across the various approaches, and then recommendations and considerations for use of data for a range of applications. The API I think will be covered under the API documentation, and we will work on additional, I think, intro videos. I know what we've been covering on some of these overviews. There can be a very steep learning curve, so we will work on additional support for new API users, and then custom reporting tools will also have separate documentation and support. Best contact information, I'll put that's support at openetdata.org. That's the best place to contact a forum. That's a great idea. I think once we make the API public and get a little bit of breathing room, a user forum would be I think that's a great suggestion and an efficient way, I think, to communicate with our user community. I just put the support address in the chat. That is the best way to contact us with questions or recommendations and feedback. I don't know when we'll make the effective precipitation data available. It's going to take us a little bit of time to evaluate different methods, review those, especially with our state partners that would be some of the key users of that information, state water management agency users, and then come to consensus on the best approach. One of the key challenges for effective precipitation is there's really not a good reference data set. There's nothing like Ameriflux or a network of eddy covariance stations. So it's a little more challenging to conduct accuracy assessments for different approaches and then use those accuracy assessments to clearly identify the most robust and consistent approach. So I'm going to say that's at least 6 to 9 months out and possibly longer. Other questions? And general questions about how to use the API or what, we welcome general questions about particular API endpoints or even just problems logging in or problems with API keys. I think I've updated everyone's API key that requested it. We understand that refreshing them every 6 months is inconvenient. We are talking through different strategies for either automated refresh or other mechanisms. So that's less of a headache both for our users and for our team. We recognize that as an issue. In terms of the DWR GSA, so part of our agreement with California's Department of Water Resources specifically provides support to OpenET to support the GSAs and to allow the GSAs to designate 1 or 2 primary consultants that would be able to retrieve anything they need for the GSA and then share that with all consultants and users working with the GSA. I don't know when that agreement will be complete. Is Robin on? I don't think Robin's on. Hopefully in the next month or 2.
I am on, Forrest. Sorry, but I missed the call out. I was multitasking. Apologies.
No problem. So the question was, when do we expect an agreement with the state of California to support the GSA usage?
I would say certainly, I mean, the expectation is that will be done by the end of the year for sure, to be conservative.
Questions? Okay, Will, do you want to share that just last slide on ways folks can help us?
Yes, certainly. So we greatly appreciate your patience as well as any feedback that you have on the existing API documentation, as well as feature requests that you would like to see just built into the API that make your life easier. So please don't hesitate to share that. We're also open to criticisms as well. So if there's something that has been consistently not working for you, or if you really just don't like the way that some of the API functionality is currently handled, please let me know. Happy to make adjustments to the algorithm and program in some additional support for people.
I'll just add that
Yes.
Will is also very modest, so praise and positive feedback is also welcomed and encouraged. So for the things that are working well, and if you find the documentation useful, that's also helpful to know.
Well, thank you. And we'd love to know, please share about how you're using the API. We've had a lot of users, integrate, different irrigation scheduling apps with this. They've built really amazing, data products, pulling data from the API and just automating that process. So we'd love to know what you're doing and, how you're using it. That'd be, please let us know. The last thing I'm going to say is, currently, we have to be mindful of the shared nature of all the compute resources at present. So if you're able to reduce shapefile, geometries and complexities, that makes things significantly less computationally taxing on our end. And I will make a recommendation for daily data that is, at present, kind of the most expensive resource that you can use. So if limiting those to just multiple point queries is best practice, we are, again, really heavily focused on making those types of queries and data retrieval much more computationally efficient and much faster, so that there doesn't need to be as much restriction based on daily data requests. And other than that, just thank you guys, thank you all so much. I know this has been the development process of this has been, a little bit slow, and we just really appreciate your patience with us. And yeah, thank you so much.
Thank you, guys.
Well, I'm planning on staying on for a little while. If people have, questions or want to get into some of the details for anything, more technical or specific with the API, so feel free to stick around if you have any questions you'd like to ask directly.
Thanks. And a couple of other things here. Ming Liang was asking about coverage. So I did want to mention, of course, that the API supports for the all of the raster endpoints, the wall-to-wall data, so the 30-meter resolution across the U.S. And we have now added data to cover most of the Mississippi River basin. So let me bring that up really quick, just if folks haven't seen this yet.
While you're pulling that, oh, never
There
mind.
it is.
Go ahead.
If you haven't taken a look yet at the OpenET Data Explorer, field view is still limited to the western 17 states, but raster view, you can see we've added, continuing to work our way east, covering most of Louisiana up through Minnesota, and I've got a good chunk of the Mississippi River Basin now covered. So data is available from the raster endpoints there east of the Mississippi. Go ahead. There's another question.
Yeah, there's been a differentiation made between daily ET availability, and I just want to make sure I understand. Is it somehow the raster? You're saying that the raster endpoints for daily ET are not available until the public release, but a different feature is available for daily ET now?
But do you want to clarify the endpoints that are available for the daily
Yes.
raster data?
So the daily data is currently supported through the time series endpoints for the raster API. So that is going to be the time series point, the time series polygon, and the time series multi-polygon endpoints. Those, again, we are working on expanding that out once we kind of better understand the cloud compute costs associated with exporting, large amounts of rasters, and as we work on more efficient ways to do that.
It's available through all of the raster endpoints. Adding the daily data to the geodatabase just makes the geodatabase too large. We would effectively need to create different databases and different servers for each year. And so for the daily data, we are planning to limit that to the raster endpoints for the foreseeable future. Adding it to the geodatabase just makes it too large, and we haven't seen demand for daily data from pre-existing polygons yet. So our expectation is that the primary usage for the daily data would be for irrigation scheduling and management applications. And for those applications, we anticipate that users would want to carefully define their boundaries and areas of interest. And so the raster API and then the custom reporting tools that would provide an even more user-friendly interface to the raster API would be the best way to support that functionality.
Got it. Thank you.
If there are particular locations where having pre-computed daily data where we see people generating it over and over again, and there's a community of users that would like to have pre-computed summaries for a particular basin or location, we can certainly consider that. But doing it wall-to-wall for now north of 4 million fields was just it wasn't clear there was use for that data, and there would be significant expense and effort required to produce it. Any other questions? General questions?
This may speak to my ignorance of the data sets, but why GridMet over DayMet for your precip data?
Good. Why GridMet over DayMet? That's a good question. So the team at DRI had conducted a number of evaluations of products over agricultural areas and had in the end recommended GridMet as the product. I think in part due to its availability and the potential availability of up to 28-day forecasts that would be consistent with the historic data. We are one of the tasks USGS has asked us to consider as an evaluation, just another look at all of the gridded meteorological products, both for historic data production or data production moving forward, as well as, and then the team is looking at different options for a gridded meteorological forecast for production of the gridded forecasted reference ET.
Okay. If you don't mind, one more question.
Sure.
So I assume you're still consuming weather station data to help when you run your models.
We are not. So we are using the GridMet data for the Western U.S. in Spatial Simus. We compiled all of the available weather station data and used those to produce bias correction surfaces, but we are not directly consuming the weather station data as an input presently.
Does that include the Ameriflux data set?
So the Ameriflux data set was only used for accuracy assessment, so we are not assimilating observations from Ameriflux. We are using those as an independent data set for accuracy assessment purposes only.
Okay, great. Thank you.
We have considered the need to update the bias correction surface periodically. So that isn't to say that we will never be re-ingesting or using the ground-based stations, but we're not pulling those in on a day-by-day, week-by-week basis.
That's good. That's kind of was my understanding. So that's good to hear. Great. This is amazing stuff. This is going to be really useful, I think. So thank you guys for making this.
Really appreciate that. I definitely want to acknowledge the work that Will and Alberto and Britta and Jody and Jordan at Habitat 7 and DRI have all done on the documentation and the API. The teams worked really hard on it, so I think it's something to be proud of.
Yeah, I want to second that. Congratulations and thank you for this extremely helpful webinar. Appreciate it.
Thank you, Jeremy. Phil asked for the historic data being made available on GE. Will new data be added? Yes, we'll add data in annual increments. We are allowing lag time for the modeling teams to review the data, do some additional accuracy assessment and verification on the data, but we will be adding data in annual increments and then also adding additional historic data as it's produced. So yes, that archive will grow. Well, we will continue to propose additions, both moving forward and then as we produce more historic data for the U.S. And we also got news that one of our partners in Brazil, Dr. Anderson Ruhoff, had received support from the Brazilian government and the Brazilian Water Agency to start work on a pilot, OpenET pilot for Brazil. So Dr. Ruhoff will be leading that effort as well. We're happy to answer any other questions. I always say I've made an entire career out of asking stupid questions. So please ask us anything. Don't don't hesitate. If any of that was confusing or covered too quickly.
I guess one question I have is if you're making some data available through Google Earth Engine and folks have to pay for Google Earth Engine moving forward, that providing direct access to the data that way, I guess how are you going to pay for the data production for the data that sits kind of behind your servers?
So, so the commercialization of Earth Engine is definitely a complication. So one of the things we're talking to USGS and NASA about is other archives to host, other data repositories to host the full, where we can host the full archive and how we can manage that. So that's one topic. We're hoping that especially as we can support a lot of the research and academic community through direct access to Earth Engine, which will be free for research purposes, that will then free up the resources we have to support other users that would not be considered academic or research. And so as we our hope is if we can shift a lot of the large retrievals, heavy usage to the users' Earth Engine accounts, that will free up resources for us to provide larger access for operational partners that don't qualify for free access. There will be at some point a level of usage where we will need to work, especially with state and federal agencies, to secure licenses for Earth Engine or connect them with the right folks at Google Earth Engine to at least explore that option.
Great, thanks.
We do fall in this. So when we started working on Google Earth Engine and building the infrastructure, of course, it was a free and open service. So we seem to have found every gray area in the Earth Engine plans for having a more balanced public access and commercial strategy. Other questions?
Do you ever intend to expand the API to include a user's ability to run a custom model with custom parameters?
No. I think that'll be that for those types of applications. That's why we'll be adding the model code for the models as they're finalized and documented to the GitHub repos. So that will allow a user to make a copy of those repos in their local GitHub repository and make modifications as they see fit.
Are all of those in Visual Basic or Python, or what are those models coded in?
In Python, built around the Google Earth Engine Python API, and some of the models have separate GitHub repos for standalone Python implementations that would run on any environment.
Excellent. I'm looking forward to that release.
Yeah, so I think GE CBOL has the repo. CBOP is there. Sims is close. Yeah,
That's a point.
So we will keep working on that. Other questions? We'll go ahead and stop the recording, but we'll stay on for another 5-10 minutes in case folks had any last questions.